In this video, we want to look at how to find number of proton, number of electron, number of neutron. Let's say this is an atom of element. The atomic number will be somewhere here. This is atomic number. And this is atomic mass. Now, if you're given a certain atomic number, x, which you don't know, and you're asked to find number of proton, number of electron, number of neutron, how do you do that? Now, let's say this is an atomic number, atomic element, and this is 11, this is 23. And then you're asked to find number of proton, number of neutron, and number of electron. Now, what is proton? Proton is simply the positive charge in the nucleus of an atom. Now we know that atomic number is the number of proton only in the nucleus of an atom. Atomic number is number of proton only in the nucleus of an atom. So the atomic number and proton number is the same thing, is 11. So for the neutron number is simply looking at the mass number. Mass number is a number of proton and neutron in the nucleus of an atom. So from the mass number, we can actually get the neutron number. There's a simple way to solve it, but let's follow the normal procedure. So I have that the mass number, or atomic mass number, is same thing as proton plus neutron. Well, I have the proton to be 11. I have the mass number to be 23. All right? So what is the neutron number? If you move 11 to the side, it will be 23 minus 11. And the neutron number should be 12. 23 minus 11 is 12. So neutron number here is 12. You can actually say 23 minus 11, that is 12. That's a neutron number. Now, for the electron number, notice there is no charge over here. Now, because there is no charge over there, the electron number, the proton number is the same thing because this is a neutral atom of element. So this will become 11. Let me show you what I mean. So this is sodium. This is a sodium atom of element, neutral sodium. Now, a neutral sodium has the electron resolving around its orbital in the configuration of 2:8. Okay, 2:8:1. Let me show you what I mean. So we have 2 electrons here. We have 1, 2, 3, 4, 5, 6, 7, 8. Let me take this one over here. So this is 8. This electrons is 10, remaining 1 to make it 11. So if I put a 1 here, so this is 11. So this is a neutral sodium. It's not ionized. All right. But immediately the sodium becomes ionized, it will lose an electron. Now let's say this is an element. Leave sodium now, or let's use sodium again. Element 11, and then mass number 23. Atomic number 11, mass number 23. What is the proton? What is the electron? What is the neutron? Now for the proton, remember, it's still 11 because atomic number is a number of proton only in the nucleus of an atom. So for the proton number, it is 11, which is the only positive charge there. All right. Now for the electrons, remember that there is a charge here. The charge, this one has no charge, so let's make this one having a charge. It's going to lose an electron. Now it will become the sodium will lose an electron and become positively charged, and then becomes a sodium ion. So what is happening there is that 11 minus 1. 11 minus 1 is 10. Why is it 10? Because 1 electron is lost during ionization. So the number of electrons in this atom of element is 10, not 11. Neutron number, of course, 23 minus 11 is 12. Let's say we have another question. We have this guy. So we have this guy is 16, and then is 32. And then we have to solve the number of protons. This is a minus 2. Number of electrons and number of neutrons. Of course, the proton number is 16 because why? Atomic number is the number of proton only in the nucleus of an atom. So this is where the atomic number is. So proton number is 16. Electron number, notice we have a minus 2 charge here. So solve for, we have to receive 2 electrons to become a negatively charged sulfur. For sodium, sodium will have to give out 1 electron to become a positively charged sodium. And sulfur, we have to receive 2 electrons to become a negatively charged sulfur. So what we have here, it will become 16 plus 2, and that is what? 18. Now for the neutron number 32 minus 16, neutron number is definitely 16. So this is how to get number of proton, number of neutron in a nucleus, number of proton, number of neutron, number of electron, any one of those. So the equations will either come charge, positive charge, or negative charge, or without charge at all. This same process, this same method will be used to solve any problem on finding number of proton or neutron or that of electron. Sometimes the question will come in commentary. Commentary, I mean, they can ask you, an element X has so amount of proton and so amount of neutron. What is the mass number? They can have a question like that. So it's a common sense question. An element has so amount of neutron, amount of proton, what's the mass number? So questions like that, you just need to draw the X because you don't know the element, place the values where you ought to place. They can say a positively charged atom of element. You have some question like that, a lot of questions. So any question that you have that is difficult for you to solve, using this method that you cannot solve, drop it on the comment section. We will attend to you. Thank you very much for your time. Have a great day.